All right, so here we're on 6.2 on the simplex method. Now here we're looking again at maximization with problem constraints in the form less than or equal to. So our goals and outcomes, we're going to learn about initial systems, the simplex tableau, the pivot operation, interpreting the simplex process geometrically, and then simplex method summarized, and finally some applications. All right, so we're going to start with the standard linear programming problem that we saw in 6.1 and starts with the I system. And we have maximizing something subject to something else. And so those things are not going to be different. They're going to be, we're still maximizing. We still have two inequalities that it's going to be less than or equal to. And then our x1 and x2 have to be greater than zero. So our non-negative constraints. And then after that, we have to convert it to an E system like we did before. We have to add our slack variables. So we'll add S1 to the first equation, S2 to the second equation. And so now x1, x2, s1, s2 has to all be greater than zero. Now, so nothing different yet. Now here's where it changes. For the simplex method, we need to actually get an initial system by adding in the objective function solve for zero. So our initial system is going to be basically our first two equations here, and then we're going to take our profit function, take everything to the left side, so I have a minus 50x1 minus 80x2 plus p equals zero, and then we still have our x1, x2, s1, s2 all have to be greater than or equal to zero. Now, some definitions. So basic solutions and basic feasible solutions for initial systems. Now, the objective function variable p is always selected as a basic variable. Now, note that a basic solution of system 3, which is our initial system, if we go back over here, that's our initial system, oops, is also a basic solution of system 2 after p is deleted. Now, if a basic solution of system 3 is a basic feasible solution of system 2 after deleting p, then the basic solution of system 3 is called a basic feasible solution of system 3. Now, a basic feasible solution into system 3 can contain a negative number, but only if it is the value of p, the objective function variable. So that's kind of a key there. Now here we're on to version 3 of the fundamental theorem of linear programming, and it says if the optimal value of the objective function in a linear programming problem exists, then that value must occur at one or more of the basic feasible solutions of the initial system. Okay, so that's kind of a key there. Now, initial basic feasible solution, the simplex process with the basic feasible solution of the initial system 3. So say we have our initial system has three equations and five variables. So in that case, it's going to have three basic variables and two non-basic variables. So x1 and x2 are going to be appearing in all of our equations, and no matter if it's the profit or the others. And then s1 and s2 and p each appear only once and each in a different equation. Because remember, if we have our equations, S1's here, S2 here, P here. Okay. All right. So a basic solution can be found by selecting S1, S2, and P as the basic variables. Now remember, P is always selected as a basic variable, so that's just something we have to do to start with. So these are going to be our basic variables, S1, S2, and P. P is always the bottom row in this case, and X1 and X2 as the non-basic variables to be set equal to zero. So these two are going to be set equal to zero to start out with. And then after that, we're going to solve for the basic variables. And so we're going to look for what is x1 is 0, x2 is 0, s1 is 32, s2 is 84, and p equals 0. And then the initial basic feasible solution where nothing is negative. So all those are positive, so that's okay. And then what we want to do is, so that's kind of what we're doing. And what we're going to try to do is we're going to set up this initial system into a simplex tableau. And this is going to be called our initial simplex tableau. So we're going to do similar thing as we've been doing. We're going to say x1, x2, s1, s2. Now we're going to have the p, and then we're going to have kind of this solid line here, and then it's going to be what it equals on that side over there. So if we go back to this, we have 32, 84, and 0. So that's going to be what's on that side. Now the bottom row is going to be the p's, and it's going to be after we've added it in to the left side over here. So it's going to be a minus 50, minus 80, 0, 0. And so it's minus 50, minus 80, 0, 0. And again, these are going to be our basic variables. Okay. All right. So that's converting our initial system into this initial simplex tableau. And we're going to do everything based on this simplex tableau. We're going to do all our calculations, and that's how we're going to actually solve our problems. All right, so there's a procedure for selecting basic and non-basic variables for the simplex tableau. So once we're given the simplex tableau, the number of variables determine the number of basic variables and the number of non-basic variables. These numbers do not change during the whole process. So it'll always be the same number of rows, same number of columns, nothing's going to change. Selecting the basic variables. So a variable can be selected as a basic variable only if it corresponds to a column in the tableau that has exactly one non-zero element, usually a 1, and the non-zero element in the column is not the same row as the non-zero element in the column of another basic variable. So this procedure always selects P as a basic variable since P column never can change during the simplex process. So, P has that 1 here at the bottom and then the zeros, and this one it's never going to change. And so we always keep that as the first variable. And then notice that these two also are going to be our basic variables. And so that's why we write them on that side over there. Okay. And then after the basic variables are selected in step two, the remaining variables are selected as a non-basic, and then the tableau columns under the non-basic variables usually contain more than one non-zero element. And as you can see, we've got, a 3 and a 4 and a -50 and -80. So they've got other items in them. So that's going to be our non-basic ones. Okay. All right, so some terminology to help us so when we get to the process of actually doing the simplex method, we'll understand it. So there's going to be a pivot operation. So basically, the simplex method swaps one of the non-basic variables for one of the basic variables. And so we're going to swap one of these for one of these. So what's going to happen is this comes down here, maybe it comes down here, maybe this one, but we're swapping one of these two for one of these two here. The P stays down at the bottom all the time, so we're not going to swap anything there. The entering variable is the non-basic variable that is entering the set of basic variables, and this is the largest negative in the bottom row will dictate this. So the largest negative in the bottom row here, so that means that this is going to enter. So this is going to become one of this side over here, one of the basic variables. Now, the exiting variable, it's the basic variable, which one on the left side, leaving the set of basic variables to become a non-basic variable. And there's some calculations to do to get to that. Then we have a pivot column. And that's going to be the entering variable column. Indicators, these are the elements in the bottom row of the tableau to the left of the P column. So the indicators are going to be all of these. So those first four are going to be the indicators, and that's where we're going to look for our negative values. Now, the pivot row is the row with the smallest quotient defined by dividing each element in the last column above the dashed line by corresponding positive element in the pivot column. And this will make more sense when we get to it. And this is going to give us the exit row for the smallest quotient. Okay, so we're going to be taking this number divided by, depending on this case, this is the largest one. So we'll take 32 divided by 2 and 84 divided by 4, figure out which quotient is the smallest. Whichever one's the smallest, then that variable is going to be the one that's leaving, whereas this one is going to be the one that's entering. All right. Now the pivot elements. So the element of the intersection of the pivot row and the pivot column. So that's kind of the intersection of those, the row and the column. And we're going to circle this for ease of recognition. And if you have colors, circling it in red sometimes makes it easy so you can see what you're looking at. Now, a negative or a zero element is never selected as a pivot element. So that's kind of a key thing to think about here when we're doing these. The negative or zero is never selected. So you can't have those be a pivot element. So if you have only negatives and zeros, that means you're done and you can't go any further. Now the pivot element never appears in the bottom row either. So you can't have it in the bottom row. So it has to be basically one of these two here. We can't have it in this one, and it can't have, if for some reason we're here and we're saying that this is going to be our entering one, well, you can't use zero, so this one is going to only be the one that works. So that's going to be the case. Now, if these are both negative, then we're done. We can't do that problem because there's only negatives, and so we can't have that as a pivot element. Now, one other thing that's very, very important is we cannot interchange rows with the simplex method. So unlike matrices, we could switch rows to make things easier. You can't do that here. And so always keep the rows the same. So that's what I was talking about when we're doing matrices. You have to keep them the same in this linear programming stuff, and that's why we have to do this. All right, so how to select the pivot element. So I've kind of talked about it a little bit, but what we're going to do is we're going to kind of go through the details. So we're going to locate the most negative indicator at the bottom row of the tableau to the left of the P column. Now the negative number with the largest absolute value, basically. And so the column containing this element is the pivot column. So that's going to be the column we're going to pivot on. So whichever one has the largest number at the bottom, that's going to be the column. And if there's a tie for the most negative, you can choose either one. It doesn't matter. Now we're going to divide each positive element in the column above the dash line. So, we're going to have the dash line here. So any of these numbers here we have up here, however many there are, we're going to take each one of those and divide them. Okay, and so what we want to do is we're going to get the smallest quotient. So we're going to take whatever's over here in this last column. There's going to be if it'll let me write, maybe. Okay, okay, now it does 5 times. There's going to be a number here. So we're going to take this number divided by whatever that is. So we're going to take this one divided by this, and then we're going to look at all of those for however many rows there are and find the one that's the smallest. And again, if there's a tie for the smallest, choose either row. It won't matter. Now, if the pivot column above the dashed line has no positive elements, then there's going to be no solution and we stop. So that's kind of a key thing. So that's why I was saying we really have to pay attention to those negatives or zeros. If that's the case, then we just stop and we don't have a solution. Now, the pivot or the pivot element is the element at the intersection of the pivot column and the pivot row. And so, say, this is the one and we have it, and that's our number. We circle it, and that way we know which one is their pivot element. Now, it has to always be positive and it never again appears in that bottom row. So that's kind of a key. Now, the entering variable is at the top of the pivot column. So whatever's up here, so say this is x2, that's going to be the entering variable. And the exiting variable is the one that's over here. So maybe that's s1. So this is going to enter and this is going to exit. And so what happens in the next thing is this now becomes x1. The column stays the same as far as their labeling, but the outside numbers over here, we can change those to whatever it happens to be as far as the next thing. All right, so to perform a pivot operation, or what we call pivoting, consists of performing row operations as follows. First, we're going to multiply the pivot row by the reciprocal of the pivot element to transform the pivot element to a 1. So if it's a 1, skip that step. So if we have a 2, and that's our point where we're pivoting, we're going to take 1/2 row, let's say it's in row 1, and replace that with row 1. And so we're going to divide everything in the first row by 2. Or if that was a 4, we'd divide everything by 4. And then after that, we're going to take and add multiples of that pivot row to other rows in the tableau to transform everything else to zeros. So if this is the row 1, this is a 4, this is a 8, and then we had our dash line, and this was a -16. Then we're going to have to take, okay, well, we'll take a -2 row 1 plus row 2, that's new row 2. And we'll take a -4 row 1 plus row 3, and that's our new row 3. And we'll take an 8 times row 1 plus row 4, and that's our new row 4. And so what happens is we're going to get a 1, and we'll keep that circled, and then a 0, 0, and then we'll have our dotted line and a 0. So we're trying to make that their pivot and everything below it or above it to be zeros, okay? Now, performing this pivot operation has the following effect. The entering non-basic variable becomes a basic variable. So if this was, again, x2, then down here, this now is x2, the row is x2. Now the exiting basic variable becomes a non-basic variable because what happens is once you get over here, maybe that was an S1, you're going to have numbers besides zeros in that column. So that's going to be kind of a key. And the value of the objective function is going to be increased, or in some cases remains the same. So that's going to kind of change too, depends on, the values down here. And on the very right side, we're going to have different numbers on this side over here. Okay, so that's kind of some of the information here. And so let's kind of look at what we do. So the kind of the purple table with the X1, X2, S1, S2, P at the top here, and then S1, S2, P, and then a dotted line here, and the solid line here. This all comes from our initial tableau. So if we go way back here, that's just our initial tableau. Okay, so that's just what we've done. Now, some people leave off these brackets at the end. Sometimes they leave them, keep them. It doesn't matter as long as you understand what you're doing. I sometimes leave them off, just keep extra lines out of the picture here. And then because this is the initial tableau, I know that this is going to be basic, this is, and this is. So then I have S1, S2, and P is always my last row. And so that's going to be kind of how it starts. And then what you do is, first step is you look for the largest negative number in the indicators. Well, these are the indicators. The largest negative is negative 80. And so we know that this is going to be our pivoting column. So that means we're going to be entering the variable x2. Okay. So the thing you do after you figure out that is you have to find the smallest quotient. So that's number two. So now we go over here and this is the smallest quotient. And I just put it to the side of the table usually. And so now I take whatever's on this side of the solid line divided by what's in the pivoting column. So 32 divided by 2 is 16. 84 divided by 4 is 21. Well, the smallest is 16. So I know now that this is the row that's going to be leaving, the exiting variable. So S1 is going to be the exiting variable. Okay. And because of that, I circle this. That's my pivot element. So that's what I need to make to be a 1, and everything else in that row has to be a 0. Okay, so that's what I have on step 3 is I need to make that a 1. And so I do that by taking a half a row 1 and making that the new row 1. Okay, so that's that. Now we can do this kind of like we did matrices. We can do, make piece by piece by piece, or like I was doing multiple things in one time. So if I do it multiple things in one time, I can then do pivot the column and make everything else a 0. So I'm going to make a negative 2 times that plus that goes to row 2, and then a 40 times that plus that it goes to row 3. So then what I'm going to do is I'm going to have a 1, a 0, and 0, and then whatever else happens out here is going to be what happens, and that's how I'm going to do it. And then I'm just going to keep repeating steps 1 through 4. Basically, find the largest negative down here, and then do the quotient, and then find the pivot row and the pivot element, and then do all the pivot, and keep doing that until all the indicators down here are all positive. Once they're all positive, we're done. Or if one of these is negative and all these up here are negative, we're done too. There's going to be no solution. So that's kind of be what we're working towards. So I'm going to pause here. I'm going to make it a movie on how to work this problem now.